Well, howdy there, Internet students. Mr. Hermanson again. Today we're going to do lesson 4.2b. I'm going to introduce you to a new type of number called irrational numbers. And we're going to learn how to do some things like estimating square roots and things like that. All right, so we've been talking about rational numbers, and we know rational numbers are numbers that can be written as a ratio. You'll notice the word ratio right in the number. So any whole number is a rational number. We found that out because we can just write it as a ratio 4 over 1 or whatever the number is over 1. Decimals that terminate like negative 2.25 can be written as fractions. We can just change those to the fraction setting. And also repeating decimals can be changed into fractions. Now, just check this out quickly here. I'll show you on my calculator. I don't want to go through the process of doing this right now with you, but I'll show you that you can change repeating decimals into numbers. At least this fancy calculator can do that. So I'm just going to make something up like 0.18, 18, and I'll go right to the end of the screen. Whoops. I'll create a repeating number. Maybe that's enough. And then I'm going to go to my math button here, and number 1 says fraction, and let's just see what it does when we do fraction. And there you go. 2/11 is the same as 0.18 repeating. Just to verify that, I'll do 2 divided by 11 to show you. There it is. All right, so repeating decimals can also be written as fractions, which means they are rational also. All right, now sometimes we get decimal numbers that aren't written, that we cannot write as a ratio. And I don't know if you know that, but when you see the decimal number, you'll notice it's really random. There's no pattern, and it goes on forever and ever. All right, can you think of some of those examples? Go ahead and try, if you can. And we have another question here I want you to think about. How many irrational numbers are there? All right, the one that students in 7th grade have seen is pi. Pi is approximately equal to 3.14152. I think that's right. But anyway, it just keeps going in random numbers. Turns out there's an infinite number of random numbers. Most times you take a square root or a third root or a fourth root or those kinds of numbers. You're going to get an irrational number. Okay, sometimes you don't, but most times you do. Okay, so when we put together all the rational numbers and all the irrational numbers, now remember, this is a rational number, this is a rational number, this is a rational number, we end up with a set of what we call real numbers. Okay, so if you have all irrational numbers and all rational numbers together, that makes the set of real numbers. Okay, now remember that every natural number is also a whole, an integer, a rational, and a real. Every whole number is an integer, a rational, and a real. Every integer is a rational and a real, and every rational is also real. And now every irrational number is a real. Let me give you a couple more examples. We said pi earlier. Anytime you have pi in an expression like 4 times pi, that's going to end up being an irrational number, but we consider those real numbers. Any square root of any positive number, where the number inside is not a perfect square, like square root of 40, those are irrational numbers. These are all irrational. Okay, and they're also real numbers. Numbers that we can't come up with a decimal number to represent, like the square root of negative 1, we call those imaginary numbers. So Don't worry about those for now. We have no reason to use those in 7th grade. But there are some numbers that are not real. Yeah. All right. So go ahead and use your calculator to find these square roots. Make sure you know where that is. On my calculator, it looks like this. I have to press the blue button first and then the X to the second button. And so if I want the square root of, say, 30, I do that. Okay. On my computer calculator, if I wanted the square root of 30, I would put 30 in first and then push that button. You see it in gray right now. Okay. So, so either way, but go ahead and fill in that chart. Oh, as you're doing this, if the answer has decimals, circle the approximately equal, and like the square root of 2 would be 1.41421. You're going to have to decide. Let's see, if the answer is decimals, so let's put, I think I'm just going to go out 3 decimal places. That's okay with me if you round it out 3. But if it has, if it goes on forever, in other words, we had to round it off, then you're going to circle the approximately equal. If it's exactly equal to some number like 1 is, then you're going to circle the equal. All right, go ahead and finish that up. All right, so on 2B, you're going to answer which square roots are not irrational. So you want the ones that are equal to a whole number. And that would be, also remember that every positive whole number has a positive and negative square root. So because a negative times a negative is also positive. So that's why we have the negative square roots. But the square root numbers that are not rational are 1, 4, 9, 16. And we call those perfect squares. And what will be the next rational positive square root number? So remember that this number is 1 times 1, 2 times 2, 3 times 3, 4 times 4. So the next rational positive number will be 5 times 5, which is 25. All right, the square root of a number that is not a perfect square is an irrational number. So if it's not a perfect square, if it doesn't come out to be a whole number, it's going to be irrational. So go ahead, like 23, there's no number times itself that equals 23, so I'm going to circle that. I'm not going to circle the square root of 9 because I know the square root of 9 is exactly equal to 3 because 3 times 3 is 9. So that's how you're going to decide. Go ahead and circle them all. So those are the ones you should have circled. The other ones turn out to be whole numbers when you do the square root. Is it possible to square a square root number? The work can be shown in more than one way, but the answer is the same. Check out what happens. So if you do the square root of 25 times itself, that looks like that in expanded form. Each of those separately are equal to 5, and you end up with 25. We could also do it by multiplying the two 25s first, which is 625, and the square root of 625 is 25. So thinking about that, go ahead and evaluate these expressions any way you like. I'll do this one like this, and then you can decide how you want to do it. You could have done the 16 squared first, but I'm going to write it in expanded form and then simplify each part. Square root of 16 is 4, and so that equals 16. Go ahead and finish those up. All right, so what did you notice about your answers? Answer it this way. Let's say we want to take the square root of some number and then square it. What will that equal? And you should notice that whatever we had the square root of in your answer is the answer. So the square root of a squared is a. So see if you can do these without a calculator. And then circle all these expressions that you think equal 36. Here's what I came up with. All right, so in Mr. Miser's math class, most of the calculators were broken. He wouldn't let students use their own calculators or phones. During one class, students experienced these problems. Samantha squared a number and got a bunch of stuff she couldn't read and then a 1. It was a very large number, but only one digit she could read was in the ones place. Without using a calculator, find all possible ones digits of the original number. Explain to Samantha how you know. Go ahead and try that. Now I picked 1 and 9 because no matter what the number is, if it ends in 1 and you multiply that by itself, you're going to do 1 times 1, which is 1. Also, if these numbers are 9, 9 times 9 is 81, so you would have a 1 at the end, and then you would carry the 8. So that's got to be a 1 or a 9. Okay. Now Steve squared a number, and he ended up with a 6 at the end. Another very large number on the calculator showed the ones place. What are the possible ones digit of Steve's number? See if you can figure that out. I think 4 and 6, because if you had a big number ended in 4, that's 4 times 4 is 16, so you'd carry a 1, but you'd end up with 6 in the end. Also, 6 would work, right? If you have some bunch of numbers and a 6, and you multiply it by itself, you'd get 36, so you'd carry the 3. Yeah. Since Mr. Miser's calculator were so awful, his students decided it was easier just to estimate. And so we're not going to get these perfect, but we are going to get as close as we can. And we know that the square root of 18 is somewhere between the square root of 16. Now I chose that because that's the whole number 4, so these are perfect squares. And the next higher one is the square root of 25, which is 5. So, so I know that we're somewhere between 4 and 5. And I know that it's closer to 4 because 18 is closer to 16. So it's 4 point something and it's closer to 4. All right, so go ahead and fill in the next. All right, so the square root of 36 is 6, the square root of 49 is 7, so I know we're between 6 and 7, but we're closer to 7 because 48 is closer to 49, 7 times 7. Likewise, square root of 68 is somewhere between 8 and 9, but closer to 8 because 68 is closer to 64 than it is to 81. All right, so look through the perfect square diagonal. Find the first perfect square that is larger than the one you want and follow the column back up, and your answer will be between the number you land on and the number in front of it. Compare the squares of those two numbers and decide which number it's closer to. So, so that is on one of the earlier pages of your packet. All right, so we're going to do the square root of 93 here on number 17. And so you have to go back to this page in your packet and go ahead and find 93 on here if you can. And if you can't, the ones that we circled, remember, in the middle, those are your perfect squares. So we're going to get as close to 93 as we can. Okay, so we know we're somewhere between these two, 81 and 100, which is between 9 and 10. So let's write that down. We know we're between 9 and 10. And then we know we're going to be closer to whichever number 93 is closer to. So if we look at this, 93 is 12 away from 81 and only 7 away from 100. So we know it's closer to 10 because 93 is closer to 100. All right, go ahead and finish those up. All right. I think we're ready to go ahead and do our homework now. Remember, if you have any questions about any of that stuff, you can ask me during the meeting or message me. Anyway, good luck with that homework, and we'll talk to you soon.